Welcome to the last week of our distance learning, and congratulations on how well you have done over the last several weeks. So this is also our last week of rational functions, and we're going to be learning to use an acronym called SHRATEY to analyze rational functions. We can use the SHRATEY steps to also graph rational functions, but a lot of the graph is more of just a sketch. We don't get a lot of detail about our graphs from the SHRATEY steps. So it really is just to analyze rational functions. Now, the rational functions that you have dealt with so far have been of the format something like this. Actually, this is probably going to show up as a minus. Something like that, where they have an H and a K. You can see the transformation form, the vertical dilation and the horizontal and vertical translations. And we are not going to be dealing with that form this week. We are going to be dealing with what we call the rational function form. And the rational function form means that we are going to have just a fraction. There will be no plus k, and that fraction will not be in transformation form. So you will not see the a value and the h value in it. You will have two polynomials, one on top, one on bottom, and the ratio of those two polynomials generates a large fraction that we will be able to analyze and kind of sketch details for. Now, we will not be asking you guys to graph these or sketch these. So the examples that I'm going to look at today, I will be providing the graph to you. You don't have to print these notes out. If you want to sketch the graph, if you are copying down these notes, you can, but it's not something that you will have to know how to do. It's just so that you can have something to compare our SHRATEY steps to the actual graphical characteristics of this function. So it's not a big deal if you don't actually have the graph in your notes. Okay, so the first thing is, of course, what are the actual SHRATEY steps? What does the acronym stand for? So S stands for simplify your equation. Simplifying your equation means you want to factor and reduce. Okay, now the equations we're going to deal with today will not simplify. There will be some things that we can factor, but nothing is going to reduce. Okay, so we will deal with the ones that actually simplify and reduce on day 3 of this week. If your equation actually reduces when you factor it, then you will generate holes in your graph. And so we will go over how to actually locate those holes on day 3. Holes are what we refer to as a removable discontinuity. I mean, you guys have seen graphs this year with holes in them. You have not generated holes for yourselves. And so you will see why it is that they happen and what they look like on day 3. Once you have your simplified equation that you are going to work with, then the actual first analysis step is to find your roots, okay, or root if you have a singular one. And the way that you do that is you set your numerator equal to 0. And remember that roots is just another word for x-intercepts. So what you are figuring out is, where is your equation going to be equal to 0? And your equation is going to be equal to 0 when the numerator is equal to 0. Okay, so we will set our numerator equal to 0, and then we will solve, and we will find our x-intercepts. Then the next analysis step is the A step. A stands for the word asymptote. And you guys have seen asymptotes several times this year. But specifically, this particular A step is talking about locating the vertical asymptote or asymptotes. And vertical asymptotes are what we refer to as non-removable discontinuities. Vertical asymptotes are the places in your graph where you have a very sharp break in your graph, and they occur when your denominator is equal to 0. So to locate our vertical asymptotes, we will take our simplified equation, we will take the denominator from it, set it equal to 0, and solve it. And that will tell us where we have vertical asymptotes in our graph. Okay? The next step of SHRATEY is the T step. We're not going to do it this year. You will be learning it in pre-cal next year. What you're going to be taught is that it's what's called the tangent or together step. What you're looking for is squared factors in the equation. And those squared factors, depending on whether they're in the numerator or in the denominator, will generate special behaviors in your graph. But like I said, we're going to not be doing it this year. It's not just because of the distance learning. We historically don't teach that in Algebra 2. It is something that you will learn in pre-cal. The next step is the E step. It's the end behavior asymptote. And there's 3 different categories. Two of them create horizontal asymptotes in the graph. And you guys have seen horizontal asymptotes before. I mean, your parent function 1 over x, that looks like this. It has a horizontal asymptote right here at 0. Okay, so you've seen horizontal asymptotes before. You also saw them even in your exponential unit. If I just told you to graph e to the power of x, your exponential functions have a horizontal asymptote. Okay, they have a horizontal asymptote at 0 too. You know, the left end of this graph never crosses 0. So horizontal asymptotes are what control the ends of your graph. We're going to deal with the 2 situations that create horizontal asymptotes this year, and then the third situation does not generate a horizontal asymptote, generates something different, and once again, you will not learn that third situation until pre-cal. Okay, and then the last step is to find your y-intercept. And of course, you find any y-intercept, no matter what unit you're in, by plugging in x equals 0 to your equation. Okay, so what we're going to do is we're going to look at just a few examples, and I'm going to show you the graph, and we're going to take the equation, and we're going to do these SHRATEY analysis steps to them. Okay, so the first equation that we are going to look at is f of x, or y equals x plus 1 over x minus 3. Okay, and I've already given you the graph. So like I said, if you want to, if you are not printing these notes out, you can just pause and sketch the graph only if you want to. Okay, but what we're actually going to do is just analyze this function. So the first step of SHRATEY would be to factor and to reduce. And so in this case, there is no simplifying step to be done. The numerator and the denominator are both linear. Neither one of them can be factored, no GCFs to worry about pulling out or anything like that. And so since there's no simplifying that needs to be done, there would also be no holes that we would need to worry about locating, because like I said, we're not doing the holes at all today. Okay, so we actually begin the analysis process with step R. Step R is, of course, to find our root, our x-intercept. And so what we would do is we would take our numerator, x plus 1, and we would set it equal to 0. And we would get a solution of negative 1. And so that means that we have an x-intercept at negative 1, 0. And we can see that right there on our graph. Okay, so there's the analysis step that agrees with this graphical characteristic. So then the next analysis step would be the A step, to find our vertical asymptote. And so the vertical asymptote occurs when the denominator of your fraction is equal to 0, because of course when you have 0 in the denominator of a fraction, it is undefined or does not exist. And so we get x equals 3. And this one gets left written like this. It's got to be written as an equation because it is the equation for a vertical line. And that vertical line does need to be graphed as a dashed line. Now you're not going to see it on the graph. It's not going to graph this for you, but you see that sharp break. You see how one side of your graph heads up that vertical asymptote and one side heads down. Very similar to the parent function, 1 over x again. Okay, so here's your parent function, 1 over x again. Remember that that graph looks like this. And so what you see is that this denominator would be equal to 0 at 0, so our vertical asymptote would be right here, and we see that sharp break. We see the two branches of our graph head away from each other at that vertical asymptote. Okay, so very similar, or actually identical to that parent function. Okay, so as we continue our analysis steps, remember we are skipping the T step for this year. You're not learning it. And so we can move on to the E step. And so here is brand new behavior and material. Okay, so the way that you determine which of the 3 categories your end behavior is going to fall into is you take the leading term of the polynomial on top and the leading term of the polynomial on bottom. That's it, just the 2 leading terms. Okay, and in this case, the leading term in my numerator is the x, and the leading term in my denominator is also x. The fact that these 2 leading terms have the same degree, the same power to them, tells me that I fall into what we refer to as the balanced category. So I have a linear over a linear, therefore it is balanced. If I have a quadratic over a quadratic, it would be balanced. Okay, so what that tells me is 2 things. The first thing that it tells me is that I'm going to have a horizontal asymptote in my graph. The second thing that it tells me is that the way that I determine where that horizontal or end behavior asymptote is going to be is I simply take those 2 leading terms and I reduce them. So if I took x over x and I reduced it, it would just become a 1. And so that tells me that my horizontal asymptote is going to be the line y equals 1. And you can see that in this graph. You see how both ends of your graph are curving and getting flat and getting really close to 1. Okay? And so we will see other situations. We will look at another one that's balanced on the examples today, and we will also look at one that's in the second category that we're going to look at this year. Okay? And so the final step of SHRATEY is your y-intercept. So the y-intercept, very straightforward. Same way you find the y-intercept in any unit with any equation, you simply plug 0 in for x. And so we get positive 1 over negative 3. And so that means my y-intercept is the point 0, negative 1/3. And so I can see that right there where it hits the y-axis. Okay, so all of these SHRATEY steps do give us graphical characteristics of this function, but that's not all we use them for. And when it comes to actually sketching the function for yourselves next year, then your teachers will also talk to you about how you know what the rest of the graph would actually look like. Okay, so now we're going to move on to a second example. The equation for the second example is f of x is x minus 2 over x squared plus x minus 2. Okay, and so if we attempted to simplify this, because it takes practice to recognize right away just by looking at it, oh, hey, this is not going to simplify. So what you always do is you try to factor. And so this denominator does factor. X squared plus x minus 2 factors as x plus 2, x minus 1. And nothing reduces. We do not have any factors on top that also occur on bottom. And so that means that there's no simplifying to do. And so once again, if there's no simplifying to do, then there will be no holes in the graph. Okay, so we don't have to worry about holes in the graph. Okay, so now we can actually begin the analysis process again. So now we move on to the R step. So we're going to confirm the x-intercept that we see on this graph. So we take our numerator, we set it equal to 0, and we solve it, and we get x equals 2. So our x-intercept is the point 2, 0, which you can see right there on my graph. Okay, then the next thing is the A step, the vertical asymptotes. And I want you to notice that this graph looks like there's two places where we have sharp breaks. Right here, there's a sharp break where the branches split apart from each other. And right here, there's a break where the branches split apart from each other. I want you to also notice that this graph has 3 separate branches, okay, which I believe you did look at earlier last week when you were graphing in transformation form. And the reason it has 3 branches is because we have 2 vertical asymptotes. Okay, so what I do is I take my denominator, and I can take it in its already factored form, or I can take it in the original form. If I take my denominator and set it equal to 0, the first thing I would do anyway would be to factor it, x plus 2, x minus 1. And so I get 2 solutions. I get x is negative 2 as a vertical asymptote, and I get x is positive 1 as a vertical asymptote, which agrees with these 2 locations on my graph. Here's x is negative 2, here's x is positive 1 as vertical asymptotes on our graph. Okay, so there's our VAs, or vertical asymptotes. We are skipping the T-step this year again. So in the last example, I probably won't even state that again. And now the E step. So now what we're going to look at is we're going to look at our leading terms again. So we take our leading term on top and our leading term on bottom. Our leading term on top is just the x, okay, because it's a linear. Okay, so the leading term is just x. The denominator was a quadratic, so the leading term of this one is x squared. And so what you see is that it's got a larger power on bottom. When we have a larger power on bottom, this is what we refer to as a bottom-heavy equation. And all bottom-heavy equations have a horizontal asymptote at the same place. They all have a horizontal asymptote at y equals 0. All bottom-heavy equations do. Once again, next year, you're going to discuss with your teachers and classes that there are some other behaviors that these leading terms would tell us. But right now, all we're doing is analyzing our function and identifying these characteristics. Okay, so we know we will have a horizontal asymptote at 0. Now we see that here at the left end, you see your graph curving and getting really flat at 0. And at the right end, it's doing the same thing. It's getting really close to 0. There's barely any separation at all. But what does seem odd, and once again, you'll discuss it more and hopefully understand it more next year, is here in the middle of the graph, our graph actually crosses that horizontal asymptote. And you guys have always been taught that graphs don't cross asymptotes. Well, not that we're going to discuss it in detail. And remember, you do not have to know how to graph these for yourselves this year, but graphs can cross horizontal asymptotes because the horizontal asymptotes are the E step. They only control end behavior. They only control the edges of your graph. They have no control over the middle of your graph. Okay, and so that's why you can cross horizontal asymptotes. Okay, and then the last actual analysis step is, of course, the y-intercept. So I'm going to plug 0 in for x. So I have 0 minus 2 in my numerator, and I have 0 plus 0 minus 2 in my denominator. And so I get negative 2 on top, negative 2 on bottom, and so I get 1. So my y-intercept is the point 0, 1, which once again agrees with our graph. Okay? And then the final example is this one. Okay? This equation is f of x is x squared minus 4 over x squared plus 2x minus 3. Okay, so once again, we go to our S step. We're going to factor to see if anything would simplify. Of course, we already know it's not going to because we have no holes today. But I factor my numerator. And my numerator factors as x plus 2, x minus 2, because it was a difference of 2 squares. My denominator also factors. It factors as x plus 3, x minus 1. So I've got it factored, but nothing cancels. So there's really no simplifying to do. And since there's no simplifying, there's not going to be any holes. Okay, so now we can begin to analyze. So I want my roots. So I'm going to take my numerator, set it equal to 0. I can factor it or not, however you want to do that. You can solve this without factoring it, but I did already have it factored. And so I get 2 roots. I get negative 2 and I get positive 2. And so I see right there, there's my negative 2, 0. And then right there, I see positive 2, 0 for my 2 x-intercepts or roots. Then I start the A step. I take my denominator, set it equal to 0. Once again, the first thing I would do is factor it. So I could have just taken the factored form that I already had and set it equal to 0. And I get vertical asymptotes at negative 3 and at positive 1. There's my VAs, my vertical asymptotes. And so once again, I see that. Here's negative 3. I see a break in my graph where the branches move away from each other. And then here at positive 1, I have another break in my graph. Okay, which once again agrees with us having 3 different branches to our graph because we have 2 vertical asymptotes. Okay, skip the T step, of course, go right to the E step. And so once again, the E step is going to look at the leading terms on top and bottom. And so the leading term on top was x squared. The leading term on bottom was also x squared. Both equations are quadratics, and it didn't reduce and simplify at all. And so this is balanced again because I have the same degree on top that I have on bottom. So I'm going to have a horizontal asymptote, and that horizontal asymptote is going to be whatever number these 2 leading terms to reduce to become. So x squared over x squared just reduces down to 1. If you, hypothetically, had a leading term of 2x squared and a leading term of 3x squared, then your horizontal asymptote would be at 2/3. Okay, so it's whatever those leading terms reduce to. And so we can see that, once again, on our graph. Here's our horizontal asymptote. And of course, once again, we notice in the middle of our graph, we do actually cross that horizontal asymptote because that is perfectly fine because HA just controls the ends. It's E, ends or edges, however you want to Think about that. Okay? And then the last analysis step is the y-intercept. So I plug 0 into my numerator, plug 0 into my denominator, and I have -4 over -3, so my y-intercept is at 4/3, which I can see that. I need to erase where it crossed the horizontal asymptote if I'm going to do that. So I can see my y-intercept right there at 1 1/3. Okay? And so those are all of the analysis steps. So what the practice problems are going to have you do is you are not going to graph. Do not stress out or feel obligated to graph. If you want to try graphing them, you can. What I would recommend is opening up Desmos or your graphing calculator. Graph these to check your analysis steps. So I want you to find all of the intercepts and the asymptotes for these three equations. So remember, the intercepts would be your x and y intercepts. So you're going to find the x-intercepts and the y-intercept. And so remember that the x-intercepts is the r-step of SHRATEY, and the y-intercept is the y-step of SHRATEY. And then your asymptotes would be your vertical asymptotes and your horizontal asymptotes. Vertical asymptotes come from the denominator. They come from whenever your equation would be undefined, which is when your denominator is 0. So that's the A step. And the horizontal asymptotes are going to be the E step. Okay, and those are the problems I want you to try for today's lesson. Thank you guys very much. See you again in a couple days.